All right, so the last few examples that we're going to do have to do with radical equations. So when you have a radical in your equation, please, please, please check your answer. So I'm going to write check my answer at the top because radicals kind of go wonky sometimes. And so you always got to check your answer just to make sure you don't have anything extraneous. So what we have is x minus the square root of 8 minus 2x equals 0. So if I can get the radical by itself on one side of the equal sign, then I can kill the radical by squaring it. Okay, so right now it's negative, so I'm just going to add it to both sides. And please notice I'm not changing anything under the radical. I'm just saying from a negative one of these, I'm changing it to a positive one of those. So my coefficient changes, but nothing underneath changes. So now what I have is x equals the square root of 8 minus 2x. And now that that radical is isolated, I can kill it by squaring both sides. So this becomes x squared, and on this side, it all pops out. And now it looks somewhat more familiar. So I see it's quadratic. So I'm going to set this thing equal to 0. So I'm going to add 2x to both sides. And I'm going to subtract 8 from both sides. So x squared plus 2x minus 8 should give me a 0. So when I factor this, and again, you can complete the square, quadratic formula, whatever, but this is factorable. So two numbers that multiply to negative 8 and add up to 2 are going to be x plus 4, x minus 2. Now, I've got two factors that when I multiply, I get an answer of 0, which means one of those factors needs to be 0. So take each factor and say what will make u be 0, and then solve. So I subtracted 4 from both sides, and I added 2. So I've solved. I've got two answers. One is negative 4, and one is positive 2, but now I need to check my work. Okay, so when I check this, if I put in a negative 4 for x, let me just rewrite. 8 minus 2x needs to be 0. When we check, we put a little question mark above that, so we know that we're wondering. So I'm going to try negative 4 first. So negative 4 minus 8 minus 2 times negative 4. I wonder if that equals 0. So negative 4 minus 8 plus 8 is 16. Does that equal 0? So now I've got negative 4 minus 4 does not equal 0. Okay, negative 4 minus 4 is going to be negative 8. So don't worry about your plus minus out here. It's only during the process of solving a problem that you need to include your plus minus. This one has already stated that it's subtraction. Okay, so this is 16, which means I get a negative 4 minus, and then the square root of 16 is 4. So now let's try the other one. In other words, I cannot use, this does not work. So negative 4 led me down a bad path. So let's try 2. So I've got 2 minus 8 minus 2 times 2. I wonder if that equals 0. So there's my x minus the square root of 8 minus 2 times x, which is 2. So I've got 2 minus 8 minus 4. Does that equal 0? 2 minus the square root of 4. Does that equal 0? And 2 minus 2 equals 0. So you checked 2, and it worked in, and it gave you a true statement. So out of two solutions that you found, you can only use one of them. So on this one, you have one single answer, and it is 2. So let's try another one. I've got the square root of 5x plus 76, and then minus 9 equals 3x minus 3. And so the first thing I notice is I'm working with a radical. I had better check my answer. Okay, I had better check my answer. So I want to get the radical by itself. Then I can start squaring stuff. So I'm going to add 9 to the other side. So I get the square root of 5x plus 76 is 3x, and negative 3 plus 9 is positive 6. And now I can square both sides. So he gets squared and he gets squared. Now do not fall into the bear trap. This is actually stating 3x plus 6 times itself. So you're going to have to FOIL that. So on the left, 5x plus 76 pops out. And on the right, I'm going to get a 9x squared plus 36x plus 36. Okay, so I FOILed it out. I just did it in my head. So I see that this is quadratic. So I'm going to pull everything over to him so it's equal to 0. So I'm going to subtract 76, and I'm going to subtract 5x. So that gives me 0 is 9x squared plus 31x, and then I have a minus 40. Okay? And I happen to notice, if you want to use quadratic formula, you can. But I need two numbers that will multiply to 9 times negative 40, that will add up to a positive 31. So these are actually my numbers, but the signs are flip-flopped. Okay? So negative 40 times 9 is going to be a negative 36x squared, but it's times 40, so it's negative 360. So two numbers that multiply to a negative 30x squared that add up to a positive 31 is going to be a positive 40x and a minus 9x. Okay? So now instead of using quadratic formula, I can do factoring by grouping. So I am going to, which quadratic formula is going to work too. Okay? I just don't like using it unless I have to. So I'm going to trash my 31x. So I have a 9x squared, and I'm going to replace it with a 40x minus 9x minus 40 is going to equal 0. So using factoring by grouping, what's common here? Well, I can pull out an x, and that leaves me with 9x plus 40. Okay, what's common here? I can pull out a negative 1, and that leaves me with a 9x plus 40. So now tell me what is in parentheses, and that's 9x plus 40. Tell me what is not in parentheses, and that is x minus 1. Okay, so I'm going to try this one first. So I've got a 9x plus 40 should equal 0, so I'm going to subtract 40, and I'm going to divide by 9. And then for this one, x minus 1 should equal 0, so I'm going to add 1. So I've got two answers. One is negative 49ths, and the other one is 1. So I'm going to leave you to check those. Okay, so check negative 49ths up in here, and check 1 up in there. Make sure that they generate the correct stuff. Okay, so now let's try something else. We have x to the 5 halves needs to equal 243. So first of all, what is an x to the 5 halves? When you have a rational exponent, which is a fancy way of saying a fraction inside your exponent, what that means is I'm actually taking x to the 5th, and I'm taking a square root. So whatever your denominator is the root that you're taking. Okay? And then you've just got an x to the 5th. But I actually have a shortcut for this. If I raise both sides to the reciprocal of this, so what's the reciprocal of 5 over 2? It is 2 over 5. 2 over 5. Okay, if I raise both sides to the reciprocal, how do I handle a power to a power? I multiply. So my exponent becomes a 10 over a 10, which is an x to the 1st. Okay? So he's an x to the 1st. Well, now, what do I do with that mess? So I told you that we are moving this week, which if you're watching this later on in the semester, I am not moving this week anymore because I'm settled. But I don't know my calculators. So we're doing all this on my phone, which means I need to turn down my brightness so you can see what I'm doing. Give me a second. All right. So we have this mess right here. And what I'm going to do, flip, thank you, is I'm going to take 243 and I'm going to raise it, so you should have an exponent key. And notice how it opens up a parenthesis for me. I'm going to raise it to the 2/5 power. And hit enter and I get 9. Okay, hit enter and you get 9. In other words, if I square 243, so 243 squared, I'm going to get a big number. And then I take the 5th root of that. Okay, so that's what all of those things mean. So let's try it again. I've got x minus 3 to the 2/5 power. And I need that to equal 4. Okay, so what am I going to do with a rational exponent? I'm going to notice that this is by itself on one side, just like this was by itself on one side. So how do I kill it? I raise it to the reciprocal power, which is 5/2. And I do that to both sides. Okay, so when I raise a power to a power, I multiply, so I get a 10 over a 10, which is 1. So this becomes x minus 3 to the 1st. And then in my calculator, I'm going to do 4 to the 5/2 power. So clear this out. 4 raised to the 5/2 power, and I get 32. Okay? So I have 32 over here. Now I'm just going to add 3. So add 3 to both sides. I get x is 35. Okay? So let's try it again. Solve the equation. So these ones get a little bit more exciting. So I've got a 36 x to the 4th minus an 85 x squared plus 49. And that's going to equal 0. Okay? And so what I'm going to try to do is I'm going to try and factor this thing. So notice it looks quadratic. So if we come back, where's my paper? Give me a second. All right. When we came back, that's a lie. Hang on, I got to find the right paper. Give me a second. Okay, let me just give you an example. Normally, it is x2, x1, no x. This exponent will always be half of this exponent. So I could have x6, x3, no x. I could have x8, x4, no x. Okay? But this exponent needs to be half of that exponent for us to do what we're going to do. So other than that, we're just factoring. Okay, so how do we factor this thing? Well, I want to see if this is a perfect square trinomial. So what I'm going to do, and the reason I'm doing that is because this is a perfect square and this is a perfect square. So I'm going to test. So how do I test? I'm going to take the square root of the first, which is going to be 6x squared. I'm going to take the square root of the last, which is 7. And then I'm going to take the sign of the middle. And then I am going to test to see if this thing actually is a perfect square. So the way I do that is I multiply first and last, which gives me a negative 42, and I double it. So it's a negative 42, and I double it, which is going to give me a negative 84. That does not match this. So I effectively just wasted my time. So now what we're going to do is we're going to go in, I'm just going to use quadratic formula, but instead of x equals, I'm going to have x squared equals. Okay, so x squared equals, and I'm going to do negative b, so that gives me 85, plus or minus b squared, so 85 squared is going to be, hang on, 7,225, minus 4 times a times c, all over 2 times a, which is going to be 72. Okay, so in my calculator, I'm going to do the square root of, so let's grab this thing and put it over here again. So I've got the square root of 7,225 minus 4 times 36 times 49, and that gives me 13. So this entire square root just turned into a 13. And that's going to be over 72. So remember, this is x squared equals. This is not just x equals. So normally this would be x2, x1. So we would say x equals. But now I've got x squared. So this is going to be x squared equals. So 85 plus 13 is going to give me 98 over 72. So 98 over 72 is going to be divide by 2, and I'm going to get 49 over 36. Okay, 85 minus 13 is going to be 72 over 72, which gives me a 1. So I did 85 plus 13 over 72, 85 minus 13 over 72. So x squared can equal those two things. Well, now I need to square root. So I'm going to square root both sides. So the square root, don't forget your plus minus, of 49 over 36 is going to be 7/6. Okay, so I've got x equals positive 7/6, negative 7/6, and then what's the square root of 1? It's either positive 1 or negative 1. Okay, so that is a good, easy way to do that, and honestly, I'm going to let this video go a little bit longer. Let's try a little easier one. So I've got x to the 4th minus 9x squared minus 22 is 0. So I need two numbers that multiply to negative 22. But so your signs are different, and when I add them or subtract them, I get negative 9. So the square root of the first goes in the first spot. And then what are my two numbers? I'm going to get a negative 11 and a positive 2. Okay, so now I can separate these. So x squared minus 11 needs to equal 0, or x squared plus 2 needs to equal 0. So add 11, and then square root both sides. Do not forget your plus minus. So x can be either positive or negative 11. And then this one, I've got subtract 2 from both sides. And then square root both sides. Don't forget your plus minus. So x equals plus or minus negative 2. Well, that's an imaginary number. So x equals either positive or negative I root 2. So you've got four answers: 11, negative 11, I root 2, and negative I root 2. And that is section 1.6.